Hi students, and welcome to another week of distance learning. We have a completely new topic that we are going to start today. In the previous weeks, we have covered a lot of basics concerning the .NET programming platform, about C#. We have learned quite a lot of things about what's new in C#9 and in .NET 5 and things like that. And with the exam last week, we closed this foundational topic. So it's time to start something brand new. It's time to start with Entity Framework. This week, I'm not going to teach live, but we will flip classroom again. So you will get the theory lesson in form of this video. You can watch this video, you can work through the examples. So you can stop the video, pause the video whenever it's necessary for you to try and recap what I gave you. While you are watching the video and working through the content, I will be live on Teams and on our Discord server, and whenever you have any problems or questions, you can ask me. So the main purpose of this video is to walk you through the most important topics of Entity Framework. It's just a beginner lesson. We will dive deeper in the upcoming weeks, but don't just watch the video. Really try the examples, try to follow along, launch Visual Studio, type in the same code that I type in, and if you have any problems, if you make a mistake, that's very good, because now you have the possibility to ask me and we will work through all your questions regarding Entity Framework. So what is this Entity Framework thing? What is it all about? You all know about relational databases. Relational databases like, for instance, Microsoft SQL Server, Oracle, Postgres, MySQL, and so on. Relational databases are built around the concept of tables. In your SQL, in your database classes, in the previous years, you have learned how to create tables. You have learned what primary keys are and foreign keys are, so you know what a relational model is. That is what relational databases are all about. But in C#, things are a little bit different, because we don't think in tables, we think in classes. These classes can inherit from each other. We don't insert a row in a table, but we just create an object, an instance of a class with a new operator. So it's somewhat similar. You could say in very simple scenarios that a class is something similar to, let's say, a row, a tuple inside of a database, and a collection, something like list of T, could be thought of like a kind of table, but it really isn't exactly the same. There are many differences. Take foreign keys, for instance. In a relational model, you have a primary key value, for instance, a number. And if you have a dependent row that refers to this row, to this primary row, you are using the foreign key, the ID of the row that you want to relate to. How does that work in C#? Well, completely different, because we have references. I can create an object, let's say customer, and if the customer places an order, the order can simply have a reference to the customer, some kind of managed pointer if you want. So we have differences, really important differences between C# and relational databases. And here comes in Entity Framework, entering Entity Framework, because Entity Framework is a so-called Object Relational Mapper, an ORM. It maps the concepts of object-oriented programming in a programming language like C# onto the concepts of a relational database. That is why it's called an object relational mapper. Entity Framework is not directly connected to any kind of database implementation. It's a generic framework which you can use for many different database platforms. Like I mentioned here some, like Microsoft SQL Server, SQLite, Postgres, MySQL, and there is also very interesting an in-memory implementation with which you can try out Entity Framework without even having a real database server. This in-memory thing is especially interesting when it comes to automated tests, because on your test server you might not have a big database and you just want to try a certain element of your code, a so-called unit, in a unit test, and there you can use this in-memory provider if you want. The latest version in production is currently changing. In fact, the thing that you see here is no longer true. Today, the new version of Entity Framework came out. The new version of Entity Framework is called Entity Framework 5, and so my demo today will already be on Entity Framework 5, which has been available really just a few hours. So this video is really using the latest and greatest bits that you can fetch from Nougat. So I will fix that one. It's no longer .NET Core 3, it's .NET 5. The Nuget packages, which are important, are called Microsoft.entityframework.core. And then you find the name of the database system that you would like to use. In our case, we are going to use SQL Server, the relational database platform from Microsoft, in order to try things out. The SQL Server is available for free. You can use either Docker if you are already familiar with Docker, but if you are not familiar with Docker, I encourage you to install the SQL Server Developer Edition or the SQL Server Express LocalDB. In fact, this is really the thing that I encourage you to install. I think it's the most convenient version of doing some experiments. Follow along my code. SQL Server Express LocalDB is exactly what you really want to have. Let me quickly show you that. SQL Server Express LocalDB, you can download it from here. It's completely free for development purposes. You don't pay anything. It runs in the background of your computer, and everything should be fine. If you want to try whether you already have SQL Server Express on your machine, chances are pretty high because you have Visual Studio installed, you can do the following. Just launch a command shell and type in SQL Server LocalDB. Oh, it's just SQL LocalDB. I'm sorry, I told you something wrong. Let me quickly start my Sumi tool. So this is the correct command, SQL LocalDB. And that should give you a nice little command line tool, SQL Server Express LocalDB, as you can see it here. And if you want, you can also say SQL, let me click here, SQL LocalDB I, and that will give you a list of SQL LocalDB instances. You should typically have this one already on your machine. This one is one that I just created for some testing purposes. So my first exercise for you is to start a command shell and try this command, SQL LocalDB. If it already works, then SQL LocalDB is already installed on your computer. Everything is fine, you are good to go. You can try the SQL LocalDB I for information and see whether you have this MS SQL LocalDB installed. If this command fails, you don't have SQL LocalDB installed on your machine, and I encourage you to go to my slides or simply Google for SQL Express LocalDB, download the installer and install SQL Server Express LocalDB. Afterwards, you can try if this statement now works. It should work. Please make sure that all of you have SQL Server LocalDB installed on your local computer, because we will use it throughout a lot of the exercises. We will use it in the exam and so on and so on. So this one would be important. So I know that some of you use a Linux or Mac environment. If you have that, then you can prefer the version via Docker. So if you have Docker installed on your computer, which if you are using Linux or Mac is there is a good chance that you have Docker installed, then you can simply download a version of SQL Server, a development version of SQL Server from the Docker Hub. Simply run this statement if you have Docker installed, and it will pull down the necessary Docker image and it will run a SQL server in a Docker container on your local port 1433. So that is the option for those of you who are running Linux or Mac. If you are running Linux or Mac and you don't have Docker installed and you still want to use SQL Server, well, you can install SQL Server on Linux too. Please Google it. You will find installation instructions, but this is the most inconvenient version of downloading and installing SQL Server. So I recommend SQL Server Express LocalDB if you are on Windows, Docker if you are on Mac and Linux. With that, pause the video. Make sure that you have everything installed, make sure that you have a SQL Server available, and once you have done that, come back and continue with the video. Welcome back! Now that you have SQL Server installed, we can write the first few lines of Entity Framework code, install the required Nuget packages, and so on and so on. Before I go into the details, I would like to point you to hopefully useful thing that I have on GitHub for you. In our classes GitHub repository, in the folder slides, you can find an Entity Framework cheat sheet. It's concise, a short summary of the most important things that you need to know in order to work with Entity Framework. I will keep it open because I need to copy some of the commands, some of the packages from this cheat sheet, and I created this cheat sheet so that you do not need to read the entire documentation. However, if you want to know all the details, the cheat sheet is definitely not enough. You can take a look at the Entity Framework documentation, and as you can see it here, it's a pretty complete and long documentation of all the things that you can do with Entity Framework Core. So you have a very good documentation on Microsoft's documentation site, and this cheat sheet is a short summary for the things you have to know in order to pass this course. Okay, so let's stick with this cheat sheet. Go to Visual Studio. Here I have an empty version of Visual Studio open, and we are going to start to code. Let's create a new project. I ask you to follow along, so please, whenever you need to, pause the video and recap what I show you. We create a console app. I will put it in my temp folder because it's good here, and I will call it Entity Framework Intro. That's a good name. The name doesn't matter. If you want to choose a different name, feel free to do so. No problem. Good. We have an Entity Framework Intro. Of course, we are in .NET 5, so we can change here the target framework moniker, the TFM, to .NET 5.0 in order to switch to .NET 5. Another thing that we do, we discussed that a lot in the last few weeks. We changed the lang version to preview in order to get the latest and greatest version of C#. In a few days that will no longer be necessary, because in a few days we will have the final release, the RTM release of .NET 5 and C#, but now it's still necessary. And last but not least, we add a setting which we didn't cover in details in the last few weeks, and I will not cover the very details now. I ask you just to trust me and add this setting, nullable enable. This nullable enable turns reference types into nullable reference types. Many of you will now scratch their head and ask, what does he mean, nullable reference types? What does this mean in detail? Trust me, it's a good idea to enable nullable reference types for applications which use C#9 and .NET 5. It's a really good thing, and it will make your code better, and we will spend some additional hours on this setting in the upcoming weeks. As soon as we have on our course topic, the topic of writing quality code with unit tests and things like that, then I will go into the details. For now, just trust me, it's a good idea. If you want to know the details, I refer to the documentation. It's not our core topic now, so let's just accept it. Good. As you all know by now, .NET 5, we don't need a main method. We can just start coding. We don't need a namespace. We will have just a single file, and we will write some demo code directly here in this file here. Okay? So, what would be the first thing that you would do if you would just use SQL with a relational database? Well, probably you will create a database. We have to postpone this step. But the second thing that you will do immediately afterwards, you will create some tables. In C#, we cannot create tables. If we want to create a data structure in C#, we do what? We create classes. And this is the first thing that we do. We create the modal classes. Those classes will be turned into tables. Each class becomes a table in the database. Granted, there are some more advanced scenarios where your classes do no longer map directly one-to-one to a single table. Such advanced scenarios would be, for instance, M2N relationships, or maybe classes with inheritance, but we will not cover that today. Some of these topics will come in the next few weeks, or they will come in the next year. For now, let's keep the modal classes simple. I would like to build a very, very simple cookbook together with you. So let's create a class, let's call it dish. Okay? A dish needs to have some kind of primary key. As normally in C#, an object has an identity on its own. It doesn't need a key like a number or a global unique identifier. It's just an object, and the object has an identity. But things work differently in databases. In databases, every row in a table needs a primary key. And therefore, if we want to use C# to access a relational database, we also must or should add a primary key to our class. And there is a really useful convention that I ask you to remember because it will turn out very, very handy throughout this course. Just create a property of type int and call it ID. If you call it ID, Entity Framework will immediately understand that this should be the primary key. It will create an integer column in your table. It will make it the primary key. And it will also automatically create values for the primary key. So you don't need to invent a primary key numbering scheme. It is done automatically. Okay? So it's an auto-incremented value. And all that goodness comes from the fact that we call this column, this property ID. So remember that. That will make your life much easier, especially if you are a beginner with Entity Framework. The next thing that we add is a title. So let's add a property, string title. Please note that in this case here, I'm using a string. I can also give it a default value. That's maybe not a bad idea. I'm using a string here. And by using a string, I'm implicitly saying that the title is a mandatory value. There must be a title when a dish is created in the database. So in the database, the column will be a not nullable column. If I would change that to string question mark, that would change the whole game. If I add string question mark, the question mark indicates that this string is optional, and that would turn up in the database as a nullable column. So please keep that in mind. And you know what? The fact that we can do that is enabled by this setting. Okay, so now you understand why this setting is really convenient when it comes to Entity Framework. In our case, title should be not nullable, it should be mandatory, so let's remove the question mark here. Additionally, I would like to add a constraint here. I would like to say that the title must not be longer than 100 characters. The easiest way to do such things is by specifying a so-called data annotation. There are a lot of data annotations. I will show you that in a second, but let me quickly type that here. Max length 100 means that the title has maximum 100 characters, and therefore in the database it is created as an nvarchar column in our SQL server with the length of 100. There are many different data annotations, and you can read about these data annotations in the documentation. Just take a look in the Entity Framework documentation, creating a model, and here you see the chapter Entity Properties. And when I scroll down a little bit, you will see that there are many different things that you can add by using data annotations. For instance, here you see mentioned the maximum length. You can specify the column data type and add, for instance, here some precisions. Oh, here you see an example for max length, and so on and so on. Okay? So take a look at the documentation if you want to know the details. For now, max length is a very good idea for this property. Let's add another property here. This time we make it optional, and this is notes. Notes of how to prepare the dish, and these notes can be a little bit longer, so we will specify max length 1000. Well, sounds good. And last but not least, we want to add optional stars. How many stars would I give this dish? Okay, it's also optional. So you see the pattern here. Question mark means optional column, and in the database means nullable column. Good. Now, a dish consists of ingredients. So we need a second class representing our ingredients. Let's create a second class dish ingredient. And before we fill in the dish ingredient, I would like to jump quickly back into our dish class, because now we have to model the relation between a dish and dish ingredients. Every dish has a lot of ingredients. Therefore, we need to model a foreign key relationship. Okay, the foreign key will be from the dish ingredient to the dish. A dish ingredient, like for instance, nuts. I need nuts for my dish. Okay, I have nuts as an ingredient, and this ingredient relates to a specific dish, and a single dish can have 0 to multiple dish ingredients. To model that, we need to add a list. Let's add a property, a list of dish ingredient on the n side of the relation. So here we can say this one is ingredients. Yeah? And let's add a new list just as a default value to get rid of the warning. So here you see one dish consists of many ingredients, and therefore we add a list here. That is important. With that, we can go to the dish ingredient class. We can quickly copy the ID, because I already told you that it's important that we have a primary key for every class that we use for Entity Framework. And I also told you, can you remember? ID has a special meaning. This one here, this one, the very name ID will lead to a primary key with an auto-generated value. Okay, let's add another quick property, string. Let's make it description, and add it to a string empty as a default value. And here we will say again max length, and we'll say 100 is enough for an ingredient description. Then we will add, let's say, a string unit of measure, in German Maßeinheit. Let's again add an empty string here and say this is the max length of 50. And then we will need an amount, and for this we will use a decimal property here in C#, amount. How many nuts or flour or apples or whatever the ingredient is, how much of this ingredient do we really need? And here we can specify now details about how to represent the data type in the database. You have to understand that there is a gap that we need to fill between C# and a relational database, because in C# we just have the data type decimal. But in a relational database like SQL Server, the data type decimal or numeric has additional properties like the precision, in German Genauigkeit. How many digits do we have after the comma, and how long should the decimal be able to become? This is something that we typically do not care about in C#. We just say decimal and we are good. But in a SQL database, we should really specify a precision. And there, again, we use, in simple cases like we are here, data annotations. We can say we have a column, as you can see it here, and we can say the type name here, the type name should be a decimal. This is specific for the database that we just used, SQL Server. Decimal is a name of SQL Server, and we specify 5,2, and that means that we have a total length of 5 and 2 digits after the comma. Good. Now we have the amount. The last thing is now very important, because the last thing is the relation from the dish ingredient to the dish. Remember, on the end side, we had this list because one ingredient relates to, sorry, wrong direction. One ingredient relates to one dish, and one dish can have multiple ingredients. This is why we use the list here. But now we are on the other side of the relation, and here we have the one side of the relation. So in this case, we don't use a list, but we add a property of type dish because there is a single dish that an ingredient relates to. Okay? We can call it dish again, and this should be optional. Let's make it optional. That's fine. Now the last property is kind of strange, but also kind of natural if you know how relational databases work, and you had a lot of courses already related to relational databases. The last thing what I add here is a dish ID. This is now the foreign key value from the dish ingredient to the dish. So this is the foreign key value, this here, where the ID, let me scroll a little bit and make that smaller so I can draw a little bit. Now it's good. This is the foreign key value that comes from the dish up here. So here we have the dish, and a single dish ID is used in our dish ingredient, as you can see it here, as the foreign key, representing the relationship between dish ingredient and dish. Okay, so again, to recap that, on the end side of the relationship, you have a list, as you can see it here. On the one side of the relationship, you have two things, typically. Of course, exceptions make the rule. There are exceptions in advanced cases. But in general, to keep it simple, and for now we will keep it simple, you add a so-called navigation property, which allows you to get from your ingredient to the related dish. This is why it's called a navigation property. And the second thing that you add is the foreign key value. Entity Framework will add the internal ID from the database that it uses to find from the ingredient to the dish. I hope you understand that in a few minutes, when we have created the database, it will become much clearer. Good. We have finished our modal. We have done the first step. The modal classes dish and dish ingredient are done. And if I compile my application, I see one succeeded. That is exactly what I wanted to see. So if you couldn't follow along while I was talking, let me show you the code. These are our two modal classes. Stop the video, pause it here, make sure you have the same code on your side in your Visual Studio, and remember, if you have any problems, I am online in Teams and in Discord and the Discord server. If you have any problems, ask me. We will share the screens and we'll take a look at what your problems are and solve them. So be right back once you have written down that code and once your application compiles successfully. Welcome back. Your modal classes work now very good, so we can take the next step. Let me increase the font a little bit so you can follow along more easily. The next step is to create a so-called database context. The database context is, let's say, the entry point for working with the database. Without Entity Framework, you would have a kind of database connection. The database context is somewhat like a database connection. It has, in fact, a database connection underlying it, but the database context contains a typed version of the database connection. So it contains entry points in order to query and add and remove and update, of course, data for all our tables. Not clear yet? Don't worry. Let's write the code and then everything will be pretty clear. Trust me. So let's add a class. We will call it cookbook context. And this cookbook context is now derived from DB context. Yeah? We currently get an error because DB context is not known, it's unknown. The reason for that is that we need to install a Nuget package that I already mentioned, and it's part of my cheat sheet here. The Nuget package that we need, you can copy it from my cheat sheet. It's Microsoft Entity Framework Core.SQL Server. Okay? So let's copy that and add that as a Nuget package. Browse. Here it is, SQL Server. And here you see, woohoo, we are already working with .NET 5. Let's celebrate this. It's the first day of availability and therefore great thing that we can already work with it. So let's add this Nuget package. It will take a few more moments, should be done nearly immediately, and we are good to go. Okay, now we can generate the using statement and the database context is here. Implementing a database context for simple scenarios, it's really simple. Once the scenarios become more complex, and we will deal with more complex scenarios in the upcoming weeks, the database context will contain more and more complex code. But for now, let's keep it simple in order to learn the basics of Entity Framework. The first thing that we do is we will create a constructor, CTOR, tab, and it will give us a constructor. This constructor takes one parameter, and you will find this in my cheat sheet. I will now tell you that here in the code, but you will copy that from my cheat sheet. It's the DB context options. DB context options off, and you specify the cookbook context, the name of the type of the database context here, and let's just call it options. You don't need to do a lot with this DB context options. The only thing that you have to do is you have to pass it on to the base class, which is DB context provided by Entity Framework. So essentially, when you create your own Entity Framework applications at the exam or maybe for the homework, you essentially just copy this code from my cheat sheet. Besides the constructor, we also add representations of our database tables, to put it in simple words, which relate to the modal classes up here. Let's write the code, okay? We add a property of type DB set of dish, and this is dishes. Okay, so this type here, DB set, represents a table in the database which is queryable. So we can query this table using SQL, or when we are in C# using LINQ, the language integrated query language that we covered in the previous weeks. Then without any database in the background, but now we will have a database. So if we drill down into DB set, you will see that DB set implements an interface which is called IEnumerable, and you all know our good old friend IEnumerable. We have covered IEnumerable. This was the basis for all the LINQ queries, for all the queries that we did in the exam last week and in the homeworks in the previous weeks. So a good old friend can be discovered here. Well, the DB set is also a so-called iQueryable, as you can see it here, because it's not just a regular enumerable like a list or an array, but it is something where you have a queryable data store in the background. In a lesson in the upcoming weeks, I will tell you a lot more details about what iQueryable is, because it is a super important interface for understanding how database queries in C# really work. For today, let's keep this, I use this term quite frequently, let's accept that this is kind of Harry Potter programming. a little bit of fairy dust, and it just works. And the thing that makes it work is iQueryable. We'll not discuss the details now. This will follow later. For now, I just want you to understand and remember that IEnumerable, it's the same IEnumerable that we already know from regular C#. So this is what a DB set is. It gives us an entry point for adding data to the table dishes, for updating and deleting data from it, and for querying data from the database. Let me quickly make a sip here. And continue. We will add a second DB set here, a DB set, and this time it's dish ingredients because we have two tables here. Let's call it ingredients. Okay, that is good. And this is our DB set. Yeah, looks good. I'm happy with that. Good. Let's compile it. Let's see if I did anything wrong. Yeah, we get some warnings here. We will ignore these warnings for now. If you don't like these warnings, then please click on the light bulb and say suppress and in source, and then the warning should go away. I will not discuss all the details why this warning is here. Just trust me. If you dislike the warning, get rid of it like that. That's fine for now. Before we can now work with the cookbook context, we need to create as our third and last part. First part was the modal, second part was creating the context, third part, we need to create a factory. With the factory, we can then create the context. Now comes an important one, and please listen closely because that is important. Creating the factory is only necessary if you create a command line application like we will do this week and maybe also the upcoming week. As soon as we switch to ASP.NET, building web applications, web APIs and things like that, we don't need to create this factory anymore. ASP.NET has a built-in mechanism for connecting to Entity Framework, and we don't need to manually write the factory. But it's pretty simple to build a factory, and you don't need to know that by heart. It's part of my cheat sheet. Trust me, it's there. You just need to copy it. Building such an context factory, such a database context factory is really not difficult. Let's write the code. Let's create a cookbook context factory. The base type is a rather long type. Design time database context factory off, and then we specify the cookbook context, the name of the DB context that we would like to create. Now this interface here, if we go to the light bulb and say implement interface, needs one single method, and this method has to create a cookbook context. Let's implement this method. Essentially, it's pretty simple to build it and to implement this method. Again, just to be sure that you can sleep well at night and that you know that it's not really difficult. Let me see, where do I have it? Where do I have my factory? Here. I haven't committed this change. I'm very sorry. I'm very sorry. I will do that immediately. I will do it live now here. You see, I have written that into my cheat sheet. You see it here, but I have not committed that to GitHub yet. I'm sorry for that. Add factory. I will do that now. Okay, and push it. And now you should have it in your course material. Give me a sec. It's pushed, and if I refresh it now here it is. You see here, you see the context factory. This is the code that we are going to write, so you don't need to know that by heart. Just if you build an app for homework or exam, just copy the code if you need it. You know what? Let's just copy the code so you see that it is really not difficult to create such a factory. Good. Let's paste it in. We just need to change the name of the context here, because here it is the cookbook context and the cookbook context. The only thing that is a little bit more complex is In fact, this here. If you take a look at the code, it's pretty simple. You just need to create the so-called database context options builder. Just remember it, just accept it. Microsoft has invented that. Copy the code and you are fine. We are not going to talk about the details here. And here you say which database system you would like to use. Use SQL Server if you want to use SQL Server. Use PostgreSQL if you want to use Postgres. Use MySQL if you want to use MySQL. In our case, SQL Server. But the tricky part here is that we have to specify a connection string. We have to specify a connection string with which entity framework can find the database server. And of course, we should never, ever write a connection string directly here in the C# code, because such a connection string could contain security-sensitive data, like for instance a database password, a database user, or things like that. So never write the connection string directly here. What we want to do instead is we want to have a configuration file, a text file, with which we can read the connection string from a configuration file. Okay, so let's add a configuration file by clicking right-click on the project, add new item. And here we can just say JSON, and then we say we want to add a JSON file, and let's just call it appsettings.json. This appsettings.json file will contain our connection string, and you know the drill from the past few weeks. In order to make sure that appsettings.json will be copied to our target folder, right-click on appsettings.json, click on properties, and here copy to output directory, if newer or always whatever you prefer. And with that, we now have a config file where we can add a connection string to our database. Understand it? I will give you a second in order to follow along and create the app settings file. Whenever you need to, pause the video, and if you have any questions, switch over to Teams or Discord and ask me. If you need any help, I'm there to support you. Good. Let's go back to our cheat sheet, because in the cheat sheet I have already added, see, appsettings.json, a sample file where you can add a connection string that shows a connection string to, in fact, a SQL local DB database. So I copy this one and paste it here. This one is okay if you run everything on local DB. This one is probably not okay. What is the second part here? Remember, we had this nice little command previously, which was called SQL local DB. And if we say SQL local DB I, we get, can remember that, a list of instances of SQL local DB instances that we have on our machine. Probably you have exactly one, and you have this one. So what you can do is you can copy this name here and put it here. Okay? Then we specify the name of the database. Let's say cookbook lesson, cookbook lesson, and the rest is fine. Okay? The rest is perfectly fine. For those of you who do not use local DB but a regular SQL server, for instance, in Docker container, you need to specify the server name or the IP address of the server here. For instance, if you run it in Docker, you can just say localhost if you want. And probably, if you are not running it on your local computer, you cannot use trusted connection, but you have to specify user with the admin user and password with the admin password. It depends on your setting. If you have any problems finding the correct connection string for your environment, again, come to Teams, come to Discord, ask me. I will help you overcome any of these problems. But for SQL local DB, it's perfectly fine to just add the name of the instance here, add a database name, and you're fine. That's it. Good. That solved this guy here, but now we need another small thing that we have to add to our code because we have to teach C# to read the app settings JSON file. And this is done with Nuget Package, which is called Microsoft Extensions Configuration JSON. Don't worry, it's part of my cheat sheet, so you can copy it from there. But now I'm just telling it to you, just add the Nuget package, which is called microsoft.extensions.configuration.json, and we will install this Nuget package and we are done. Again, listen very closely. This is only necessary if you build a command line executable. Once we switch to ASP.NET and we build web APIs and web applications, you do not need to add this Nuget package anymore because ASP.NET has it built in automatically. Nevertheless, it's important for me that you understand that in the background, this is the guy who reads app settings JSON. Later on, it will be abstracted away from us, but now we have to do it manually. So this is the Nuget package that you have to add, and once you have added this one, you can generate the usings and your application should build successfully. Once succeeded, that's exactly what I wanted to see. Let me quickly check whether I didn't forget adding the Nuget package. Configuration, let's see. No, I didn't add the configuration stuff yet, so let's do that. I want you to give the best possible material, so the cheat sheet should be complete. So with that, let's go here and let's copy this value here. Go to our course material, here it is. Let's go to the cheat sheet, and here at the beginning, here, to read app settings JSON add .NET add package. So note, not necessary in ASP.NET. Okay, so now you have this note in your cheat sheet. Let me immediately add this and extend sheet here. So now you have it online in your material and you can copy it from there. You don't need to know it by heart. Okay, good. Now we have three things. We have here our modal, we have here our context, and as long as we are not in ASP.NET Core, we have our context factory, which we can use to create cookbook context objects. That's nice. Let's build it again. Good. We will now take a quick break. Please make sure that your context and your context factory look like this. Make sure you can compile everything. If you have a problem, please tell me, because now we move to the next topic. We will take our context and generate a database from our context. This requires a few steps that I will show you in a minute. Welcome back. It's time to generate the database from our database context. Good. Let's take a look at the necessary steps. The first step is a step, of course, all steps are mentioned in the cheat sheet. The first step is a step that you only need to do once. Once you have done it, it's fine. It's a one-time install step. You need to install the so-called entity framework tools, and you need to install them globally. So if you have never installed the entity framework tools before in your machine, or if you are not sure, then please run this .NET tool install --global.NET EF in a command line. Okay? If you have an old version of the global.NET EF tool, then you can use the tool update command instead of the tool install command. Just make sure that you have the latest version of the entity framework installed. If you haven't, you will get an error, so don't worry. Additionally, in order to make this thing work, we need to add another Nuget package to our application. We need to add the Nuget package, Microsoft Entity Framework Design, to our Nuget package, to our application. So copy this one, Microsoft Entity Framework Core Design, switch to Visual Studio, and with that, go to Manage Nuget Package, and add the next Nuget package which we need for Entity Framework, which is Microsoft Entity Framework Core Design. This one, install it. Good. And we are happy. Good. Everything is fine. Now, two important steps that you need to understand. There has to be somewhere some C# code which is responsible for creating the database from your C# classes. So what we need to do is we need to take these classes and somebody needs to turn these classes into database tables. So somebody needs to create, oops, that is not what I wanted. Somebody needs to create a database from your C# classes. And that has to be done by certain pieces of code. Now we could write this code manually, writing code that turns our C# classes into database structures, but that's boring. That's a boring task. Luckily, the .NET Entity Framework tools can generate the code responsible for maintaining our so-called database schema. Database schema would be the tables, the columns in the tables, and so on. This code can be generated. And the name for this generated code is migrations. Migrations because this code migrates the database structure from one version to the other. In our case, there is no database yet, so the first initial migration creates the database and the tables. And whenever we change something in these classes, we need to add an additional migration, which will, when you run your application for the next time or when you execute certain .NET Entity Framework statements, which I will show you, which will take your changes to the C# code and reflect those changes in the database by, for instance, adding a column to a table or adding a completely new table. Understand what I mean? So migrations take your changes in C# and transfer them into the database by generating behind the scenes, create table statements, alter table statements, and things like that. In more advanced scenarios, you will definitely manually create at least parts of your migrations. But we are here in the basics. Therefore, generating the migrations that Entity Framework give you is perfectly fine. We don't need to touch this code. Okay? So let me show you how you do that. I will here open this folder in File Explorer and go into a command shell. The first statement that I'm going to execute is called .NET EF. This is now the global entity framework tool. This is the tool that you just installed with this .NET tool install. .NET EF migrations add, and then you can give it a name. I will call it just initial migration. Just initial is fine. You can choose any name. It's just an arbitrary name for your migrations. Let's run this guy. It builds the application. It will look for the database for the context. Okay, and then I don't reference Entity Framework Core Design. Didn't I add that a second ago? I have it here. So you know what? Maybe I need to rebuild my solution. Let's check whether I'm in the right folder. Entity Framework Intro. Let's try it again. Yeah, much better. For whatever reason, I had to rebuild my apps, something. Maybe I didn't save in Visual Studio. Probably I forgot to save the changes. But now, as you can see, it's fine. So don't forget to save your changes in Visual Studio and then add this statement here, .NET EF migrations add with the name of the migration. And if we take a look, we now have here a subfolder with migrations. And here you see initial.cs. That's our initial migrations. You can also take a look at the generated code. It's pretty obvious. If you take a look, for instance, here we build the ingredients table, and it contains, for instance, here a description, and it contains for SQL Server an nvarchar 100. This is what I meant with the code for generating the database, for generating the create table, alter table statements, and so on, is auto-generated with this tool. Very, very handy tool. In the simple scenarios that we cover now, we don't need to manipulate these migrations, don't need to add things, so that's perfectly fine. Now we have a C# app which contains some code in order to create a database. So let's create a database. How do we create a database? The necessary statement is included, I think at the very end, yes, here. Here you see the EF migration add. The necessary statement that we have is this one or this one. You know what? Let's start with this one. We will rarely use it in our course because it's a more advanced scenario, but it's somewhat interesting. So let's copy this one, .NET EF migrations script, and run this guy here in the command line. It will take a second, and you see now Entity Framework tells you what it will do to the database, what it will execute on the database level. In this case, it will create the table dishes, it will create the table ingredients, it will set some indexes, it will set some foreign key values and things like that. So you can take a look at the underlying SQL script. And how is it generated? From the migrations. Here you see it. And how did we generate the migrations? With our statement .NET EF migration add. And where did it take the information from? From our modal classes. Here, dish and dish ingredient. I hope you understand the step-by-step modal in order to generate a database. Nice. If we would now change our dish class and we would like to extend our database, we would need to create another migration by using the .NET EF migration add. I think you got the idea. Did we generate the database yet? No, because we just generated the script. We never executed it. Don't worry, we don't need to execute this script manually. We just need to do a little bit different command. It's part of my cheat sheet. It says .NET EF database upgrade. Okay? If we do that, it will again compile our app. It will generate the, update, of course. Here you see it. Update, not upgrade. I'm sorry. .NET EF database update. It will compile our app. It will run the script, applying migrations, and now we have a database. I can prove you that because I already have a small little tool here which I can really encourage you to also use. It's called the Azure Data Studio. It's a really nice tool for managing SQL databases, including local DB. And as you can see it here, I already connected to my local DB. I can open up the list of databases, and if I refresh the list of databases, I now have the cookbook lesson. See that one? If I take a look at tables, you now see that we have two tables here, dishes and ingredients. Can you remember what I told you about the key stuff and so on? Here you see we have the primary key. Why do we have a primary key? Because we have an ID property. What about the foreign key? Let's take a look here. You will see here the dish ID. Can you remember we had that in C#? So I think now you get the idea. From the C# classes, through the migrations, we generate the database. Okay? Good. So now it's your turn. You have to compile your app. Of course, it should compile successfully. You have to add the migration. You have to take a look at the SQL script. Take a look at the script. Take some time to take a look at the generated code. And finally, create the database. Last but not least, take any kind of SQL tool. I encourage you to download the Azure Data Studio. It's completely free. It's open source, just like Visual Studio Code. and then open the connection to your local DB and check whether the tables have correctly been created. Once you have done that, come back to this video, pause it while you're working on this exercise, and if you have any problems, I told you that before, I will repeat myself consciously, come to the Discord server or the Teams meeting, and I will do my very best to help you overcome any problem. See you in a second. Welcome back. I assume that you managed to create the migrations, to execute the migrations, and to create the database successfully. Very good, congratulations. So now we can start writing a little bit of code that really accesses the database and adds some sample data. I have thought of a little bit of sample data, and it can happen that I will now copy in some code, but only a little bit of code. No, in fact, I will type it because you also have to type it. So I will share your pain, I will feel your pain, and we'll write the code together. The first thing that I would like to do is now, the topic is now we want to work with the database. We want to insert data, we want to update data, we want to delete data, and we want to query the database. The first thing that I'm going to do is I'm going to create a database context, and hopefully you can remember we have a factory for that. So let's create the factory, new cookbook context factory, and then we can use the factory to create a DB context. Let's store this one, var context equals to, and this context at some point, oh yes, it requires the args, the command line arguments that we can pass in here. At some point, this context has to be closed. Well, in our case, the application is ended because it's a command line tool. But to keep it complete, always write a using here, because the using will make sure that the context is properly closed, okay? So remember, when you create the context, add a using statement. Don't worry, these two lines will completely go away once we move towards ASP.NET Core. ASP.NET will create the context for us. It will make our life a little bit easier. For now, you have to understand what's going on behind the scenes, so we have to create the database ourselves. Good. Let's say console write line, I will create a dish, a recipe for a dish that is my favorite dish for breakfast. We will add porridge for breakfast. Good. The first thing is we want to add some data. So let's create porridge, a new dish, and this dish has a title. This title is breakfast porridge notes. This is so good. It has stars. Let's start with 4 stars, okay? Because we need to be able to change something, and of course we'll switch it to 5 stars later on, okay? And now we want to add this row, this porridge, to the database. And it's surprisingly simple. All you need to do is you need to say context, this is our database context, dot, remember the database context down here has a DB set. And we can refer to that. So dishes.add and simply add the porridge. The add method does not immediately write the porridge to the database. We could add additional dishes or ingredients or whatever we have in our database. And once we are done, when we are done adding or updating or deleting all the data that is relevant for our database change, let's say transaction, then we have to call a very, very important method. We have to call the method save changes async. Await context.save changes async. Please remember that. Don't forget that. If you forget this guy, nothing is written to the database, because this is not adding data to the database. It's just registering the C# object for being written to the database once you will call save changes async. Now we are done, so we can say added porridge successfully. Good. Let's give it a try. I will run this application and hopefully I didn't do any mistake. Oh, that looks pretty good. Add porridge for breakfast, added porridge successfully. If you didn't follow along yet, this is the code that you need to add. Pause the video until you have added this code and until you have run your application successfully. If you have run your application successfully, then you go to Azure Studio, Azure Data Studio, right-click on Dishes, select top 1000, and here it is. We have our famous breakfast porridge, and this is so good. So we have added our first record to the database. Now I want to point out one important thing. Here you see the ID. We got an ID of 1. I told you that the ID will be auto-generated, and here you see the result. We did, if we take a look at the code, never set the ID of the porridge here. It was auto-generated by the database. So at that point in our code, we did not know the ID of the dish yet. But after the save changes, we know the ID of the porridge. Let's give that a try. Let's change the code a little bit and add here a note. Let's say ID equals to porridge.id. Good. And in the database, I will right-click on this row and just, I will right-click on this row. No, I need to edit data. Then I can right-click on the row and delete it because we have to re-add porridge. And now again, to make very sure that you understand what I mean, here we do not add the ID. Then we do the save changes and magically Entity Framework will save the data row to the database and it will fill our ID after it has done the save changes async. So we then have the primary key in the database in our very dish object that we created here. Let's try that. Yes, the new porridge has the ID 2 because the database creates a so-called sequence, and although we have deleted one dish, it will not reuse the number 1, it will give us the next available number, and that is 2. So, experiment successfully done. The porridge ID is known after inserting the porridge. Okay? This is a very, very simple insert. What can we do if we want to delete something? Let's first do it manually, run it, and delete the row. And now I want to do the deletion as our second experiment here in the code. Deletion is, to be honest, very, very trivial. You just say here, console write line, removing porridge from database, just a note, and then we say context dot dishes dot remove, and then we just specify the data which we already got from the database. In our case, we added it in the database here, added it to the database here, so we can immediately tell the database, hey, I have an object, you gave me that object previously, so I now want to remove it. And what method call must not be forgotten? Correct, save changes async. So again, if we really want to remove the porridge, we need to say save changes async and maybe print another statement on the screen. Let's say porridge removed, okay? Please add that code. This is the code that is relevant. And once you have added it, run it. And now it should say edit porridge, removing porridge, porridge removed. So if I now go to the database and run it again, there is no porridge because we created and we delete it immediately afterwards. So this is the code for now for simple scenarios with which you can remove data. The next demo scenario that I would like to do with you, I will add it here right in the middle between adding and removing data, is updating data. In our case, I would like to set the stars for the porridge from 4 to 5. How do we do that? Well, it's really trivial. All we have to do is change the property stars, and which method must not be forgotten? Correct, save changes. So let's do that. Copy this one, paste this one, save changes async. Maybe we add another log message here, change porridge stars to 5, and here changed stars. Maybe this is a good status message. Okay, so all we need to do in order to update is update the values in C# and magically, through a so-called change tracker, I will tell you more about Entity Framework Change Tracker in the upcoming weeks. Through this change tracker, Entity Framework knows and understands what you have changed, and when you call Save Changes Async, it will automatically update the database for you. Let's give it a try. Run it. Adding, changing, removing, no error, everything is good and everything is fine. Please take a moment, change the code or add the code. Now we have 3 experiments. We have the add experiment, we have the delete experiment, it's here, and we have the update experiment. All 3 should now work. Take the time to write the code, try it, take a look at the database, do your own experiments, and be back once you are happy with inserting, updating, and deleting data. And then we can continue. The next thing is kind of obvious. It's querying data. Querying data means that we want to read data, maybe with filter criteria and things like that. And we already know LINQ, and the good news is that Entity Framework can translate your C# LINQ queries that we have practiced together in the last few weeks. It can translate these LINQ queries into SQL. So you do not need to write SQL manually. Let me show you what I mean. Let's add here a little bit of code, say console write line, checking stars for porridge. I'm getting hungry when writing this code here, okay? So let's check the number of stars that porridge currently has in the database, okay? Yeah, of course, we have the porridge already in memory, but let's say we don't have it. We want to reread the content from the database, okay? So let's say var porridge, var dishes equals to context.dishes.where, and we can just write an arbitrary, not completely arbitrary, but just a LINQ query that you already know, d equals to, or goes to, d.title.contains, something like this, and let's say porridge, okay? So we want to have all the dishes where the title contains the word porridge. This is a LINQ query, and it is automatically translated to SQL behind the scenes by Entity Framework. And then, okay, in our case, we just know that the result contains 1 row, but before we can consume the result, we have to execute the query. What do I mean with execute the query? Can you remember what I told you a few weeks ago? LINQ query are not executed immediately. They are executed when you iterate over the result using for each, for instance, or count, or sum, or toList, or toArray. Any of these methods execute the query, and here we have exactly the same. So in order to execute the query, after saying .where, we need to add another method, and typically you say something like toList or toArray, but never use the synchronous method. Remember what we had at the beginning of this year, or I think 3 weeks ago? Async programming with Entity Framework is now really important because we now are no longer just in memory, we are really querying a database, and I told you a lot about async programming. If you can't remember, go to the YouTube channel and rewatch the video about async programming. So always use the async method like this, and then we add an await, and now we are happy. Now we have a list of dishes where the title contains porridge. Well, in our situation, we already know that we have to have exactly one result. So we can say if dishes.length, count not equal 1, then we will pull what? Console error, something really bad happened. Porridge disappeared. Sad smiley, something like this. Of course, this will not happen because we know that there is porridge in the database because we just added it. Console.error.writeLine, of course. If we have porridge in the database, no problem. Then we can say porridge has what dishes first element dot stars. Understand it? Once we have toList async, we have a regular list here in this variable. It's just a list. It's in memory, and we can do all the crazy things that we can do with lists which we have in memory in C#. Okay? So let's give that a try and let's see whether porridge has 4 stars. And as you can see, porridge has 4 stars. Yee-hoo! If I change my code a little bit, if I make a conscious mistake here, something like this, of course we'll get an exception later on, but first we should see a nice little message. See that one? Porridge disappeared. Oh my god, I'm very sorry. So we see these queries really work. They are really executed against the database, and with that here, that is just a simple example for any kind of link query that you have written so far in memory. We can now execute it against the database. Remember queries that we did. We did things like counting, sum, group by, where, select, first or default. All these things that we had in the last few weeks are applicable here. You can use them, and now they are executed against a real database. So I will not go into the details of link here because we have done that already. Please try this next experiment by adding this code with a link query. And once you have done that, ran this application successfully, come back. If you have any problems, come to me in Teams or Discord server. I will help you overcome any problems. We have one single thing left that we need to work through together. I would like to show you how to turn on logging so we will really see the SQL statements which are issued against the database. Okay, this will be the last step that I show you, but for now, try the link query against the database and come back once you did that. Welcome back. At this point, I assume that you have successfully written the C# code using Entity Framework and that you have inserted data, updated data, deleted data, and queried data from your SQL Server database. The last step, as I told you, is now that we will turn on logging in order to take a look behind the scenes and see what's going on our database. In order to turn on logging, we have to add another Nuget package. Let me check whether I already added this Nuget package to the cheat sheet. Yes, it is here. if you want to print generated SQL statements, add this Nuget package. You see it? Microsoft Extensions Logging Console. So let's go to our Visual Studio. Here it is. And go to Manage Nuget Packages and install our logging console provider. There are many different logging providers, and for more elaborate scenarios, for more real-world applications, you would probably use other logging frameworks like, for instance, Serilog. Once we switch to ASP.NET, again, we don't need to add this logger manually. It's done by ASP.NET automatically, but I think it's a good exercise to understand and learn how these basic principles work, even without such a huge framework like ASP.NET. I hope you find that interesting too. In that case, you don't have a choice. Just follow me and add the logging console. Good. Nice. We have added the logging console, and the good news is that you only need a single line of code in order to turn on console logging. All you need to add is this method. We copied this code from our cheat sheet previously. This method useLoggerFactory. And this logger factory, of course, we need to generate the using statement, and with that we have this statement correctly. And just this single line of code will give you a glimpse into how Entity Framework generates queries and how it does its changes to the database. Okay? So store this one and run the application, and then we'll take a minute in order to take a look at the output. What you see here is that here you see it, that our logger has created some outputs. For instance, this is the first insert statement that was generated for adding porridge as a breakfast dish. You see, it is an insert statement like you would probably have written it too manually if you would have used the SQL Server directly. You see the insert into, you see it's using a parameterized version, so you don't have the constants here directly. That is good, believe me, that's a good thing. And here you see some magical things. I'm not sure how deep you are in SQL. This will give you back the identity of the row and things like that. Just trust me, just trust Entity Framework. This insert statement makes perfectly sense. The next output is also pretty interesting, because with the next output, we would like to check the stars for porridge. And here you see that, here you see that you have a SQL statement. I would like to draw your attention specifically to this output here. Here you see the like statement. Remember what we had in C#? Contains. In C#, in the link query, we had contains. So if the title contains somewhere in the text the word porridge, I want to have it as a result. And Entity Framework is smart enough to translate the C# contains method into a like query. Like means it has to contain the word porridge somewhere in the text. And here you see the percentage signs at the beginning and at the end, and these percentage signs are wildcards for any number of characters. So anything, then porridge, and then anything again. This is pretty much what contains does in C#, and therefore it makes absolute sense that Entity Framework translates contains into this like percentage porridge percentage. Understand? Hope it is understandable. Let's quickly go back to the C# code to just refresh your memory. Where we have it, here we have it. Where title contains porridge. This is what I meant. This is what became like. Next one. The next one was updating the porridge, the stars, 5 stars for porridge. And you see, again, No big surprises, just an update statement, and we are setting the stars, just the stars. It magically found out that the stars have been changed from 4 to 5, so it's just updating the stars. And last but not least, here, down here, we have the delete statement. At that point, I think I don't need to go into the very details because it's kind of obvious that we are deleting the dish porridge by its primary key. This is what Entity Framework really generates behind the scenes. And with that, we have taken a closer look behind the scenes and saw what's going on the database. With that, I would like to, don't forget, try that on your own, please. Uncomment this line, add the necessary Nuget package, which I mentioned, and you can find it in the cheat sheet, and try that. Take the time to really try that and take a look at the SQL statements and come back as soon as you have done that. Okay, at that point, I hope everything is clear. I hope you could follow along all the exercises that I showed you. I hope you could successfully recap the experiments that we did here. Please save your code somewhere on your laptops, because in the upcoming weeks, you will get homeworks. And these homeworks will it will be necessary to create model classes, to create database contexts, to create database context factories, to write some insert, update, delete, select code. And maybe this small exercise that we did today will be a good copy template for some code snippets that will come in handy in the upcoming weeks for your homeworks. If you haven't understood everything completely, don't worry. It's just the beginning. We have a lot of weeks just dedicated for Entity Framework. We will practice this stuff a lot. We will recap what we have seen today, and we will definitely take a more deeper dive into Ling, into the change tracker, into how Ling is translated into SQL. You will learn a lot more details about Entity Frameworks in the future. For today, thank you for listening. Thank you for doing the exercises. I hope it was an interesting lesson. See you.